This is a video guide for helping students solve arithmetic word problems by breaking them down and representing them in a programming language. The target audience is upper elementary students, but it can also be used with younger students. First, let's log into Pencil Code. Once we've logged into Pencil Code, we can create a new program by clicking New in the upper right. And let's call it Word Problems. In this example, we're going to solve the problem. Michaela is going to the store to buy fruit. She buys 2 apples, 2 oranges, 2 bananas, and 1 lemon. How many citrus fruits did she buy? So to solve this problem, we're going to start in the operators menu. And we're going to first drag out a variable block from the operators menu. That's this first block at the top. And what we're going to do is we're going to create a variable for each fruit that Michaela buys. So instead of X here, we're going to write orange to represent the number of oranges she bought, which is 2. And then we're going to write apple for the number of apples that she bought, which is 2. Banana for the number of bananas she bought, also 2. And last, lemon for the number of lemons that she bought, which is 1. So what we've done so far is we've created a variable for each fruit that Michaela bought. And this helps us to represent the word problem in the computer as a program. And then we can use these values to actually solve the problem. So the problem asks, how many citrus fruits did she buy? So next we can set another variable and we can call it citrus. And then we can use these previous variables to calculate exactly what citrus is. So we can do this in a number of ways. We can just type directly in here, orange plus lemon. And if you do that, you'll see it sort of represents this plus block. If we don't want to do that, we can also find the add 2 numbers block in the operators menu, and we can add orange and lemon. One thing to watch out for is that you have to type the variable names exactly in this place so that when it calls the value of a variable, so basically when it sees orange, it's going to go up to orange and take the value of orange and stick it in here. So it'll replace this with 2 and the value of lemon. So that'll replace it with 1. However, if you misspell it, then it won't recognize the previous blocks and it won't be able to get that value. Now the computer knows the value of what citrus is, but it doesn't have a way to tell us yet. So now we want to give it a way to tell us what the value of that is. And we're going to pull out a write block. And we're going to delete hello in there. Sometimes you have to hit delete and backspace to get the quotes gone. And you do want the quotes to be deleted because if you have any quotes, it's going to write exactly what is in those quotes. So for example, if I write citrus with quotes, it's going to write citrus over here. However, if I write citrus without the quotes, then it's going to call the value of this variable and write the value of that number instead. So you can see now it says 3 instead. So now we have our answer to our original question, which is how many citrus fruits did Michaela buy? We can also make the problem a little bit more complex. So if we wanted to know how many citrus fruits Michaela bought, as well as make sure that she's not going to buy too much fruit at one time, we can also add another variable called total fruit. And in total fruit, we can make it equal to the orange plus the apple plus the banana plus the lemon. And that gives us both the value of how many citrus fruit she bought and the total fruit that she bought. Then, just like with citrus before, we can write what the value of total fruit is so that we see how much total fruit she bought as well as how many citrus fruit she bought. So first it writes citrus, which is 3. and it writes total fruit, which is 7. So you can work with students to make more or less complex word problems. And then the students can also make their own word problems for students to solve. One interesting thing to note about making this programming representation of the problem is that the setup is always going to be the same. So once you represent the problem as these variables, you can then use that information in different ways to answer different questions that you have about the data. One last thing you can do is if you don't just want this 3 and 7 over here, you actually want a complete sentence that says how many citrus and total fruits you can do. You can combine both a string, which is anything that's within these quotes, so it'll be typed exactly as it's written, plus call the value of a variable. So if we, in these quotes, say the number of citrus fruits is, and then we can either add a comma here or a plus and write citrus. And that will give us the number of citrus fruits is and the value of citrus. So let's try that. So you can see that here. Probably want to add a space at the end so that there's a space before the 3. We can get rid of this block since we know what that is. And then we can do the same thing for total fruit. The total number of fruit is, let's try it with a comma this time. So this confused the computer a little bit. It's trying to make this whole thing a string. You can see because it's got the quote here at the end. So you can either use the plus instead, delete that, and do the plus. That didn't work either. Let's see. Oh, we still got the quote here. There, that fixed it. Or if you want, one of the things that I like about pencil code is that you can use these blocks interfaces, or you can also go to the text interface. So in the text interface, you have much more control over exactly what you are doing with the code. So instead of plus, we could use the comma here. And then because we're basically telling it that we know what we're doing over in the text-based side, we can then convert back into blocks and it will convert it properly rather than trying to make total fruit part of the string. So let's get rid of this block so we don't have 2 blocks of total fruit. And there we get our whole sentence responses. The number of citrus fruits is 3 and the total number of fruit is 7.